Hello, and welcome to Technology Today. It is June 30th, 2024, Season 1, Episode 19. I am Mayor Watt. I run ohmTown.com. Welcome to the show. Today we're going to be talking about ultrasound brain healing, hidden asteroids discovered by citizens, fins collect humidity and release it, new crops 5 times faster, the Large Hadron Collider unraveling the universe, biofuel from Kudzu, pumping carbon into a hole, innovative blood monitoring chip, Asteroid Day Revelation, and non-coding RNA Superhighway. The show is in a time machine right now because I was not able to do the show last night. So today is basically making up for yesterday's lack of show. So stick around. We've got all 10 articles all lined up. Oh, the sentient AI from the future is not available at the moment. They're working on some big project. I don't know. It has to do with a Terminator body, I think, but we'll see. See you in a little bit. Just going to do the intro. All right, welcome back. So, first article for today is over in Technology Today. It's a channel at ohmTown.com, but it's also one of our podcasts and a stream here on Twitch and over on YouTube. I simulcast to both, and there's a Discord and a Patreon, and everything is all linked together at ohmTown. So do a search for ohmTown and you'll find us. If you're interested in Technology Today, specifically the show notes, you can actually type in !TT in the chat over on Twitch. I don't have the bot signed in to YouTube. So you can get the show notes from the YouTube video, though, if you are interested. After 60 days, Twitch drops it off entirely. Like the whole VOD and everything is gone. So I store everything over on YouTube as well as the podcast and locally, of course. So anyway, and if you want the podcast, you can hit !pod. That will display all of the podcasts. And if you want the rest of the commands, you can type in show notes, and that'll pull up all of the shorthand for basically the channel commands to get the show notes for each individual show. They've all been updated for the weekend, but not all the podcasts have been published, such as Technology Today. And right after this, I'm going to do 4-Wheel Tech, which is another show. Okay, so this article is over in the Technology Today channel at ohmTown.com. MIT's ultrasound breakthrough, a new era in non-invasive brain healing. MIT's implantable impulse device could become an alternative to the electrodes now used to treat Parkinson's and other diseases. MIT engineers developed a hair-thin ultrasound device. What's really interesting, and I'm really tempted to publish all of the submitted articles because there has been a lot of discussion lately with Parkinson's, and it's one of those maladies, for lack of a better term, illnesses that we're starting to learn stuff about, but we don't know what really is going on. But research is ongoing, and we're going to eventually find it. It's almost as complex as, I would say, it's almost as complex as cancers. Very personal, not a one shot fits all type of solution, and we end up treating the symptoms. So let's go over to, or not. Something's going on with my browser. Oh gosh. So MIT's ultrasound breakthrough, a new era in non-invasive brain healing. It's by Anne Trafton over at Massachusetts Institute of Technology. And it shows a picture of the impulse device that contains ultrasound transducers and electrodes that are gold colored in this image. encapsulated within a polymer. So this is interesting. They're ultra small ultrasound transducers and electrodes. So to activate them, I guess they're being imparted in something, but I'm really curious about this. And they're basically doing deep brain stimulation by implanted electrodes that deliver electrical pulses to the brain. It is often used to treat Parkinson's disease and other neurological disorders. It's essentially disrupting the chaotic flow of electrical impulses that cause things like muscles to contract or to cause, what do they call it? Tremor. So MIT researchers, I'll continue that little statement here. However, the electrodes used for this treatment can eventually corrode and accumulate scar tissue, requiring them to be removed. And that scar tissue is very difficult to resolve. So, and depending on where it is, it's impossible to resolve. So MIT researchers have now developed an alternative approach that uses ultrasound instead of electricity to perform deep brain stimulation, delivered by fiber about the thickness of a human hair. In a study of mice, they showed that this stimulation can trigger neurons to release dopamine in a part of the brain that is often targeted with patients with Parkinson's disease. And it says, by using ultrasonography, we can create a new way of stimulating neurons to fire in the deep brain, says Kanan Dagdevaran, an associate professor in the MIT Media Lab and the senior author of the new study. This device is thinner than a hair fiber, so there will be negligible tissue damage, and it is easy for us to navigate this device in the deep brain. Yeah, the delivery device, though, is always bigger than the device itself, though. I find it really encouraging, though. Eventually, we'll figure out what the genetic rationale is for Parkinson's and be able to treat that with other technology that we'll talk about as we go through today. I think towards the end, we'll probably, the last article today. Oh, and all of the show notes are in the chat right now. So if you are interested, you can definitely just type in !TT again, and you'll find it. It's over at Twitch, though. It's not on YouTube because of the way that I have to connect ohmTown to YouTube. Anyway, there's the device. The new approach uses ultrasound delivered by a fiber about the thickness of a human hair. It's pretty cool. And the biggest thing to solve was that corrosion, which naturally would happen around anything that's electrical and exposed to, something that allows it to make direct contact with pretty much any conductive moisture. Kind of gross, but hey, it is what it is. To precisely modulate neurons, we must go deeper, leading us to design a new kind of ultrasound-based implant that produces localized ultrasound fields. To safely reach those deep brain regions, the researchers designed a hair-thin fiber made of a flexible polymer. The tip of the fiber contains a drum-like ultrasound transducer with a vibrating membrane. When this membrane, which encapsulates a thin piezoelectric film, is driven by a small electrical charge, it generates ultrasonic waves that can be detected by nearby cells. So it says that it's tissue safe and there's no exposed electrode surface, and it's very low power, which bodes well for translation to patient use. You do have to be very, very careful with these devices, though, particularly around other medical equipment, as far as I understand it. Interesting. So it's powered by wires that are in gold right here. Pretty cool. Okay, I'm going to keep going, though. Let's move on to the next article. This next article is over in TechnologyToday as well. Stellar sleuths. Citizen scientists and AI uncover hidden asteroids with Hubble. Deep sky exposure yields telltale evidence for asteroid moving across the celestial background over 4 billion years ago. The 8 major planets around the sun formed 14 billion years ago or something like that. Wait, no, I mean Earth did. What is going on? What am I trying to say here? Yeah, now 4 billion years later. So over 4 billion years ago, 8 major planets around our sun formed by sweeping up debris from a vast disk of cloud and gas surrounding the sun. This is common in the planet birthing process, and the Hubble Space Telescope was the first to optically see similar accretion disks surrounding newborn stars, providing a peek into the solar system's formative years. Now 4 billion years later, the planet construction yard is still cluttered with leftover debris, except that it is and it isn't. But anyway, it's all kind of... So people are looking for asteroids, and they've got this Hubble Space Telescope image of the Barred Spiral Galaxy, UGC 12158. Looks like someone took a white marking pen to it. In reality, it's a combination of time exposure of a foreground asteroid moving through Hubble's field of view, photobombing the observation of the galaxy. Several exposures of the galaxy were taken. What is evidence in the dashed pattern? The asteroid appears as a curved trail, due to parallax. So yeah, that's it right there, showing the asteroid. What's really interesting about this is it used to be done by humans looking at multitudes of pictures, circling a dot, and then taking another transparency and laying it on top and looking at that. But nowadays it's a whole bunch of data, and they essentially run an AI against it to say, or to look for translational differences in the direction that it's going. And then that is something that's out of bounds. So if everything is going in one direction, let's say clockwise, and another one is going off in a different direction, it's no longer part of that static object. It's dynamic still, it's changing, but it's still, everything is in unison turning the dial, except for something like an asteroid that's cutting across it in an opposite direction or obtuse angle. Astronomers recently used a trove of archived images taken by NASA's Space Telescope to visually snag a large unseen population of smaller asteroids in their tracks. The treasure hunt required perusing 37,000 Hubble images spanning 19 years. The payoff was finding 1,701 asteroid trails, with 1,031 of the asteroids previously uncatalogued. So quite a big discovery. About 400 of these uncatalogued asteroids are below 1 kilometer in size. So they even cataloged the size of them. That's pretty amazing. So volunteers from around the world, known as citizen scientists, contributed to the identification of this asteroid bounty. Professional scientists combined with volunteer efforts with machine learning algorithm to identify the asteroids. It presents a new approach to finding asteroids in astronomical archives spanning decades. So I don't know what the years for the observations were. I don't think it says it here. Interesting. So just to make sure I said this is actually from the Space Telescope Science Institute and published at scitechdaily.com. I'm going to go on to the next article. It's over in Technology Today as well. Small absorbent fins collect humidity and release the liquid when heated. Clean, safe water is a limited resource, and access to it depends on local bodies of water. But even dry regions have some water vapor in the air. And there are animals that actually synthesize the air or water from the air. It's quite intriguing. They catch it on their ear tips or something and then drink that. Lizards do that in the morning. They catch the dew. Pretty interesting. Geckos and stuff like that. Other animals. Anyway, the American Chemical Society put this article together. It's over at techexplorer.com. And they refer to this as a simple, compact system. First collects moisture from the air, and then when you heat it up, it evacuates that area. It's almost like capillary action, it seems. So to harvest small amounts of humidity, researchers have developed a compact device with absorbent, and they say adsorbent in the title, but in the article itself, it's with absorbent coated fins that first trap moisture and then generate potable or potable water. When heated, they say the prototype could help meet growing demands for water, especially in arid locations. The work has been published in ACS Energy Letters. And see, I don't know if we're pulling a ton of water out of the air, we're going to change the dynamic. And I just don't know. Obviously, it's at a volume that is kind of surreal when you think about it, to make this actually impact the atmosphere. But look, we're already impacting the atmosphere since our industrialized period. Earth's atmosphere holds trillions of liters of fresh water as vapor, but that's around the entire world. But it's challenging to collect this colorless, transparent, and dilute gas. Previously, researchers developed systems that trap dew or fog, pooling the liquid into containers, but in dry areas that don't have much dew, special materials like temperature-responsive hydrogels, metal organic frameworks, or zeolites, which are crystalline aluminosilicates, may help pull small amounts of moisture from air and release the water when heated. One of the things that I've talked about several times here in Technology Today are the zeolites and MOFs, the metal organic frameworks. These things are kind of, I don't know if they're the latest, but they're the new hotness in that people are scientists are talking about them and doing a lot of research with them. So these absorbents need to be practical for real world use. They need to be able to be incorporated into compact portable devices. And so these researchers developed humidity harvesters that can fit in both of those categories. And all you have to do is heat them up and they kick off the moisture, which makes sense to me as long as the heat is at a lower temperature. So for proof of concept demonstrations, they created a device with 10 small absorbent fins placed side by side on a copper base plate, about 2 millimeters apart, a distance that maximizes moisture capture from desert air containing 10% relative humidity. Within an hour, the fins saturated and then released the trapped moisture once the base reached 184 degrees C. That seems like an extraordinarily high amount of temperature. So I wonder why it didn't just evaporate the small amount that it would capture. Extrapolating to 24 collection cycles, the team calculated that 1 liter of absorbent coating on the fins could produce up to 1.3 liters of potable water per day in air with 30% relative humidity, a volume 2 to 5 times greater than previous developed devices. Interesting. Our next article is over in the Hatch Ideas channel. We are creating new crops 5 times faster, and they reference artificial intelligence in increasingly helping the arable farming sector. Suzanne Byrne is the author over at bbc.com that put the article together. And it says here, quote, "Weather and the climate are maybe the number one risk to our company," says the boss of U.S. flour firm Shepherd's Grain. Based in Idaho, the business sources wheat from farmers across the U.S. Pacific Northwest. As weather patterns become more unpredictable, Mr. Bunch says, I need to have a plan B and plan C in case plan A fails. So using current and past data, such as from satellite imagery and temperature and rainfall readings, and combining that with future projections, Climate AI aims to give farmers the most accurate possible and locally tailored weather forecasts. from 1 hour to 6 months ahead. It then advises on exactly when to plant and harvest particular crops and predicts their yields. But it just doesn't seem macro enough to me, but that's okay. Microclimatic changes do not equal necessarily a long-term trend, but climate change overall is obviously an issue. So yeah, I don't know how. Plus, a lot of things, mergers and acquisitions and all of that, are consolidating control, and our food safety, I think, it was at a peak and now it's declining again because of mergers and acquisitions and the loss of farmers. So by the time some seed companies do this, i.e., look forward at the weather, helps our growers decide which crops to plant, the platform knows when to plant and when the crop will start flowering and producing seed. By the time some seed companies do this in, say, 10 to 15 years, the climate has already changed. We're running against time to launch new seed varieties. So they're developing new seed varieties that are more robust for the incoming climate, which, let me tell you, I think all of this kind of sucks. At some point, we're actually going to have to start growing, like what I do, microgreens in regional indoor hydroponic farms. So I grow my own microgreens to avoid having to, I don't know how to describe this, but there's a lot of loss in natural farming, predation, climate change, quality in general. I know that I can grow enough microgreens to fulfill all of the nutritional needs for the ohmTown mansion, the mayoral mansion. Anyway, with increased pressure on crops at the same time as the global population continues to grow, could AI be key to developing new varieties that could better cope with extremes of weather? I would probably say, yeah, AI can actually help, but not everybody has access to it. So they say that they're funded by Bill and Melinda Gates Foundation. This is using AI to help breed more resilient crops. Specifically, the AI is helping speed up work called phenotyping. That's what I just got done saying, basically creating new seed through genetic manipulation, not necessarily genetic manipulation in editing the genes, but taking specific seeds. And because we know what the phenotype is, we can merge them together, grow them, pollinate, maybe even do genetic modifications. But, that's a dangerous, we don't necessarily know what the hell we're doing. So yes, that phenotyping work traditionally relied on the human eye, but humans are not doing this consistently with high levels of precision necessary to make subtle yet important plant selections. So they say that it can be over 30 degrees C in the field. It's just tiring, fatigue effects, data quality. Yeah, I agree. So AI and computer vision can actually reduce a lot of that, but it's only as good as the input. So if the data that decides this is the type of green and the leaf length and the curl of the leaf indicates this and that and the other, there's all kinds of data, metadata, from looking at the plant. Who knows what the end result is going to be, other than we know that bad data in means bad data out. So hopefully they're they're always trying to remedy that. So for example, with different tomatoes, there's some small differences in genomes that give them different traits. For example, different flavors, pesticide resilient profiles. Our machine learning program is able to take these small differences across a number of varieties and see which genomes are important for what traits. And we used to do this kind of stuff by, like it said in the article, human vision and observations, consuming it and doing chemical testing and stuff like that. Now we're doing it with automation and it's speeding up everything, but it's getting expensive which means that smaller companies can't compete because they just can never get enough capital to compete with these larger mega corporations. Let's keep going though. The next article is over in Technology Today. Milestone achieved by unraveling the universe's fundamental forces at the Large Hadron Collider. Researchers at the University of Rochester, working with the CMS collaboration at CERN, have made significant advancements in measuring the electroweak mixing angle. So the article is over at scitechdaily.com. Lindsay Valich from the University of Rochester put the article together. And this is the Large Hadron Collider. Building on their extensive involvement at CERN, the University of Rochester team recently achieved incredible precise measures of the electroweak mixing angle, a crucial component for the standard model of particle physics. Their work helps explain the fundamental forces of the universe, supported by experiments like those conducted at the LHC, which delve into conditions similar to those after the Big Bang. Let's see here. The recent measures of the electroweak mixing angle are incredibly precise, calculated from collisions of protons at CERN, and strengthen an understanding of particle physics. The CMS collaboration brings together members of the particle physics community from across the globe to better understand the basic laws of the universe. In addition to BODEC, the Rochester cohort to the CMS collaboration includes principal investigators Regina Demina, a professor of physics, and Aaron Garcia Bellido, an associate professor of physics, along with postdoctoral research associates and graduate and undergraduate students. So a lot of people went to work on this. So the primary purpose of the LHC is to explore the fundamental building blocks of matter and forces that govern them. It achieves this by accelerating beams of protons or ions to nearly the speed of light and smashing them into each other at extremely high temperatures, and the collisions create conditions similar to those that existed at fraction of the Big Bang, the start of the universe, basically. What happens when the particles collide, or when the protons collide, is they break into component pieces and hit sensors that get developed all around the LHC collision site. And then from there, they get to they calculate the various mathematics, the angle that it breaks from. And what happens is, as it hits certain detectors, the further out it goes, the more data relates back to that collision. But they always are updating the sensors. So the CMS collaboration recently performed one of the most precise measurements to date related to this theory by analyzing billions of proton-to-proton collisions at the LHC and CERN. So previous measurements of the electroweak mixing angle have sparked debate within the scientific community. However, the latest findings closely align with the predictions from the standard model of particle physics. So it basically implies that we have a better understanding, and that our calculations based on theoretical application of verified experiential knowledge means that we're on the right track to understanding certain concepts. So understanding the weak mixing angle sheds light on how different forces in the universe work together at the smallest scales, deepening our understanding of the fundamental nature of matter and energy. Eventually, we'll be able to understand, even to a greater degree, quantum physics, which get weird at times, like two things that are quantum entangled, and then you pull them apart and bring them any distance apparently, and then read one means that it immediately connects to the other entangled particle, and whatever the distance. And so when you know one, you know what the other one is. It's quite fascinating. But let's keep going. The next article, I need to do something real quick. Sorry. 1 second. The clicks you hear are me trying to remedy something. So the next article is over in the Technology Today channel again. Biofuel from Kudzu vines and branches boost energy efficiency. So leftover branches and kudzu vines from logging are repurposed as carbon neutral fuel to generate electricity. And this is kind of, I don't know, depending on how they are referring to this. It looks like they're referring to this as being turned into a biofuel and not just burning it. National Research Council of Science and Technology put the article together. It's over at techexplore.com. Leftover branches and kudzu vines from logging are repurposed as carbon neutral fuel to generate electricity. Biomass made from wood and forestry waste in the form of small pellets or chips can be co-used as fuel for thermal power plants. It serves as an important raw material that can replace fossil fuels and achieve carbon neutrality by absorbing carbon dioxide during its growth through photosynthesis, according to the International Energy Agency, or IEA. Biomass-based power generation is expected to represent 7% of renewable energy generation by 2050. I thought that they're synthesizing this into something other than what it is, but they're just pelletizing the or making chips of the biomass, right? Oh, pardon me. So I took a break yesterday to save my voice because I seem to be losing it, but apparently it's still bothering me. Anyway, on the other hand, this technique demands high temperatures of 300 degrees of Celsius. 300 degree of Celsius? Okay, there must be a translation thing here. High temperatures of over 300 degrees Celsius and results in energy wastage while drying. Furthermore, the equipment can be corroded by the production of the minerals such as potassium and sodium. The research team devised a kind of wet process that utilizes steam, resulting in production or reduction of mineral production and heat loss. Pardon me 1 second. These materials were challenging to incorporate into dry torrefaction process and were previously discarded or unused. So now they're taking the material. It appears that they're just drying them out. The small biomass particles are then placed in a device to be compressed into a pellet. So yeah, they basically lowered the temperature by putting it inside a device and drying it out. They say here that it weakens the chemical bonds, making them easier to break down. Subsequently, the rapid drop in pressure causes the raw materials to break into smaller pieces. To me, this is kind of sounding like not dehydrating, but freeze drying, because pressure allows you to do a whole lot of manipulation of the materials itself, pulling moisture out of it primarily. The biomass particles are then placed in a device to be compressed into a pellet form for use in thermal power plants. Thermal power plants are basically you throw some object into it and it burns. So to achieve optimal performance, the pellets are made efficient and of uniform quality by adjusting the combinations of chemical composition, temperature, pressure, and the compression ratio of diameter to length. So it's pretty wordy in that they are basically making pellets. All right, let's keep going though. The next article is over in Non Sequitur News. That's another one of our shows. We have 7 altogether. 6 are weekend shows, 3 on Saturday and 3 on Sunday. And that 7th one is Non Sequitur News, which is a daily news show that grabs 10 articles from across ohmTown.com. And we talk about it every day, Monday through Friday at 8 p.m. and Saturday and Sunday at 5. So scientists want to dig a big hole and pump carbon into that hole in a $60 million pilot project to help stop climate change. And I think that this is kind of absurd because the planet isn't static. It's pretty dynamic. And if all it's going to take is breaking this stuff open and it's going to off gas, much like cement is a huge carbon dioxide sink and it off gases constantly. They say that reactive basalt rock across the planet could turn CO2 into rock at the bottom of the ocean. The article is at Business Insider. Morgan McFall Johnson is the author. And so what's going on here is they have this little summary here at the top. Scientists want $60 million to try trapping carbon dioxide in the sea floor off the coast of Canada. They say reactive basalt rock across the planet could turn CO2 into rock at the bottom of the ocean. And they say offshore carbon capturing factories may help fight climate change in the future for a steep price. So let's see here. Powered by their own wind turbines, the floating stations would suck carbon dioxide out of the sky or even out of seawater and pump it into the holes in the seabed. The scientists call their project solid carbon because if it works as they expect, the CO2 they inject will forever be rock at the bottom of the ocean. And no, I don't believe that for a moment. That makes carbon storage very durable, and it's not about belief. There's science behind it. So I'll have to do a deeper dive, ironically, into this, because all it takes is heating and fracturing the rock and like an earthquake or a volcanic eruption. And while it might be okay there at the time, you don't know what's going to happen just because it's basalt and it hasn't moved in 2 million years. So it says it's not yet certain whether these oceanic carbon removal factories would work as expected. First, the scientists need about $60 million to test a prototype. And they talk about removing carbon from the air and from the sea. But they don't really talk about how it gets done. But they do mention an article, not an article, but they do mention something that we've mentioned previously, which is in Iceland, a project called CarbFix has proven a small-scale version of this process, dissolving CO2 in water. Yes, that's sparkling water, and injecting it into underground basalt. Within 2 years, the CO2 gas mineralizes, becoming rock deep underground, but it's still CO2 gas in mineralized form and will eventually off gas. But there must be some more research that I just haven't seen. It's pretty obvious. That said, solid carbon is no substitute for the basic immediate measures that climate experts worldwide are calling for, including swapping fossil fuels for renewable energy and reducing the carbon emissions of our food systems. All right, so let's keep going, because they don't really talk about how it's done. They just say that it's going to get pumped down into these holes, and in time it will mineralize. Okay, the next article is over in Technology Today. Powered by blood, innovative chip provides real-time health monitoring. Researchers have developed a portable device that utilizes blood to generate electricity for immediate medical diagnostics. This lab on a chip technology is something that interests me, because the Theranos attempt kind of piqued my curiosity about this, mainly because I thought that they were on the right track. But when you do a little research into it, you find out that there really isn't a one-stop shop for blood testing, because particularly with one little drop, but we'll get to that here in a second. The article more will go into more detail, but the problem is that there's different chemistries used to attain different results. So if you're looking for one thing versus another, you're going to have a different testing strip itself, and that is destructive in its assessment. And you can't take the blood from that and put it in another. Well, I've tried it directly myself, and you don't get reliable readings. So and the samples, that the testing strips themselves are keyed into certain data. So when you're using a device, it has to understand that this testing strip has this type of chemistry in it. It gets a little bit more in the reads anyway, but this article, Powered by Blood, Innovative Chip Provides Real-Time Health Monitoring, is posted at scitechdaily.com. University of Pittsburgh is the source. And they say that they've developed it to generate electricity for immediate medical diagnostics, and that the system on a chip, or lab on a chip, aimed at combating the global rise in metabolic disorders, measures blood conductivity to diagnose conditions like diabetes instantly, especially in underserved areas. But the problem there is this is a unitasker device. But they say global surge in metabolic disorders, diabetes, osteoporosis, metabolic disorders that are burgeoning throughout the world, especially in developing countries. That's all health related and genetic related disorders. The diagnosis for the disorders is typically a blood test, but because the existing healthcare infrastructure in remote areas is unable to support these tests, you need something that is possible to be out in rural areas or underdeveloped areas. Conventional methods also have labor-intensive and invasive processes, which tend to be time-consuming and make real-time monitoring unfeasible, particularly in real-life settings. So, blood electrical conductivity is a valuable metric for assessing various health parameters and detecting medical conditions. Blood is basically a water-based environment that has several molecules that conduct or impede electric currents, says Dr. Alan Wells, the medical director at UPMC Clinical Laboratories and executive vice chairman, section of laboratory medicine at University of Pittsburgh and UPMC, and Thomas Gill III, professor of pathology, Pitt School of Medicine, Department of Pathology. And the quote they say is, glucose, for example, is an electrical conductor. We're able to see how it affects conductivity through these measurements, thus allowing us to make a diagnosis on the spot. Yes, and that's about fidelity. So making it high resolution enough that it can detect at a low amount of power and when it shows enough resistance, then you get a reading. But again, it's this one task. It's this unitool. It's this one thing. So you're going to have to make a bunch of different ones. The researchers are proposing an innovative portable millifluidic nanogenerator lab-on-a-chip device capable of measuring blood at low frequencies. The device utilizes blood as a conductive substance within its integrated triboelectric nanogenerator, or TENG, T-E-N-G, not Tang, the drink. The proposed blood-based TENG system can convert mechanical energy into electricity via triboelectrification. So I find it compelling, and this is, I think, a prototype device that's self-powering, and then they, of course, use AI models to directly estimate blood electrical conductivity using the voltage patterns generated by the device. So once they get enough readings, the level of the integrity of the result would be on par or superior to what is done with testing strips or physical lab assessments. Arguably, the physical lab assessments are the highest quality. I know through testing glucose, depending on the quality of the tester, you will get many deviations from what is correct or what is assessed in the lab. So I hope that they go to great lengths to verify the integrity of this data. Okay, we got to keep going though. The time machine for this show and our next show only gives me an hour, so I got to get this done. The Asteroid Day Revelation explored the massive meteor crater in Arizona from space. The meteor crater in Arizona, formed by a meteorite impact 50,000 years ago, provides valuable insights into the geological processes of planetary bodies. The the article is over at scitechdaily.com. The European Space Agency put the article together, and there you go. You can see a meteor crater. I've seen this. It's actually pretty interesting. I've always been fascinated by the fact that this hasn't been weathered away. Everything else seems to have been weathered away. There are other meteor craters that are filled with water, like Meteor Lake. Formation of the crater was about 50,000 years ago. A nickel iron meteorite estimated to be 30 to 50 meters or 100 to 165 feet wide smashed into North America and left a massive hole. Massive is subjective. The violent impact created a bowl-shaped hole of over 1,200 meters across and 180 meters deep. During its formation, millions of tons of limestone and sandstone were blasted out of the crater. Oh no, what's going on with my browser's going a little nuts. Pardon me. And you can actually see, like, it hit and then blasted stuff out, and you can see that there's heavier items closer to the rim, that the rim was lifted up, and it just kind of cascaded away. It's almost like you can tell which way the wind was blowing or the direction of the impact, because it looks like things are blown towards the northeast of the picture. I don't know what true north is on that picture, but anyway. So crater preservation and importance, studying the crater impact craters and asteroid monitoring. There's a bunch of different content in this article, and I find it really interesting that now you can actually check it out online. During its formation, millions of tons of limestone and sandstone were blasted out of the crater, covering the ground for over a kilometer in every direction with a blanket of debris. Large blocks of limestone the size of small houses were thrown onto the rim. The wide perspective of this image shows the crater in context of the surrounding area, and the impact occurred during the last ice age, when the plain around it was covered with a forest where mammoths and giant sloths grazed. Pretty cool. I dig this kind of stuff. So over the past 2 decades, ESA has tracked and analyzed asteroids that travel close to Earth. ESA's upcoming Fly-Eye telescopes will survey the sky for near-Earth objects using a unique compound eye design to capture wide-field images. And I think that's what we really need to focus on, because right now we can only look in certain directions and only in a narrow field. It's like 1% is what's observable. Okay, so let's go on to our last article for the Time Machine episode. This article is over in the Mobile channel. Non-coding RNA acts as a superhighway for gene expression, according to a study. The function of non-coding RNA in the cell has long been a mystery to researchers, and I still think it is. Unlike coding RNA, non-coding RNA does not produce proteins, yet it exists in large quantities. I think we just don't know what it's for yet. University of Göttingen over at phys.org put the article together, and it says the research team from the University of Göttingen has now discovered an important function of the antisense RNA, or AsRNA. It acts as a superhighway in cell transport and thus accelerates gene expression. The results are published in Nature. RNA, or ribonucleic acid, plays a central role in the translation of DNA information into proteins. There are different types of RNA. One of them is mRNA, or messenger RNA. It's a type of coding RNA that and its job is to transmit the building instructions for proteins from the DNA in the cell's nucleus out into the cytoplasm, where other cell components translate them into proteins. In addition to coding RNA, there are large quantities of non-coding RNA. Much of the non-coding RNA is produced as the complementary strand to mRNA and is therefore referred to as antisense RNA. Their function has been unclear for a long time. So Kramer's team discovered that AsRNA combines with mRNA, which is then preferentially transported from the cell nucleus into the cytoplasm. This means that the cell translates the information from the mRNA into proteins faster than it would without the AsRNA. Therefore, AsRNA serves as a booster for gene expression. So it's kind of like a carrier signal at a higher rate to send more data faster, whatever the other signal is. Kind of like boosting the waveform as well. You put two signals together, and when they are resonant, they amplify. So this is necessary for the cell in many situations. For example, when confronted with harmful environmental conditions or stress. This work is the next step from the team's earlier basic research, also published in Nature, which showed the mRNAs activated under stress are no longer subject to quality control. So they just get that stuff out. Pretty cool. All right, folks. Well, that's it for today's Technology Today show. I only have an hour for each of the shows today until 8 p.m. tonight, when we'll do non sequitur news. But with that in mind, I'll see y'all later. But before we do that, I always do this. We're going to ride some AsRNA and RNA, non-coding RNA, back to the front page of ohmTown and then over to Technology Today. And we always have new articles there. So go and check out ohmTown.com. It's not driven by ads. There's actually one at the bottom of every page, and that's it. It's great on mobile. It's actually custom built for mobile as well as desktop. And once you're a member, you can subscribe to individual channels, block stuff, hide things. Like if I don't want to see this, if I'm in the front page and I don't want to see something, I can just swipe it away if I want to save it. So that will hide it and that will save it. And then once like I said, once you're a citizen, you'll have access to ignored and saved articles so that you can go back. And once you've ignored it or saved it, it will either be in that or that, not forever, because you can actually move it between each other. But it never ends up back in your mainstream. So anyway, and a bunch of other stuff. You can chat with other people and you can post comments. So for instance, back in the Biofuel one, you can make replies. We allow for Giphy. We have a Discord, YouTube channel, of course, etc., all kinds of stuff. So be sure to come and hang out with us as well here in twitch.tv/ohmTown and YouTube, youtube.com/ohmTown, where we have people sometimes come and hang out. Definitely download the podcast, like and review everything everywhere, please. That's the only way that we can get discovered. And would love to see you here in chat. Thank you very much. Bye-bye.